I think the biggest danger here is that I'm going to show you a bunch of stuff and you won't be able to make any sense of it, and you'll try to figure out where that was. So at the beginning, I'm going to point you to where things are. Everything I talk about is on one of these three places, and then go from there. Sound good? Okay, people are hearing me. Great. All right, so at Anaconda, we run two different main overview sites. One is pyviz.org, and the other is holoviz.org. And these are different because holoviz.org is all the tools that we develop in my group. So all these things, these are all tools that came out of my group. We all work on them continuously. Whereas PyViz is a step above that. It tries to cover all of Python data viz. And so any tool that is available for Python that is really a Python tool and not just some, like a GNU plot, for instance, is not there. There are a few things that can be used from Python that are not covered. But in general, if it's a Python tool, it should be on this site. And so if there's an omission, please let us know. It's organized by categories. If you find a problem, like if things are called geospatial, but you guys think that your tool is not geospatial, I don't know. I'm not an oceanographer. I don't know the difference. Let us know, that sort of thing. So basically, go to this site to find out, is there a tool to do this? This is all the tools there are that are not very niche domain-specific tools. These are meant for the general purpose tools that are available in Python. And I won't talk about these. I'll talk about our own group's tools. And these are ones that we created specifically to fill gaps in the ecosystem. Like we show up, we see what's available, and then we try to get our job done, and we see the disconnect between what the job we're trying to do is and what the tools that are available are. And every time we do that, we end up making another tool. That's why this keeps getting longer. We don't like making new tools. Well, it's fun to make new tools, but we're trying to get our jobs done, and our jobs are generally to help our various corporate or government clients get their jobs done. But each time, like GeoViews, that came from working with the UK Met Office, and they wanted to be able to easily visualize data with projections. And our existing tools didn't do that. Other people's tools didn't do it very well. We ended up with GeoViews. Data Shader came when people we were working with were trying to plot larger amounts of data. And we said, okay, we need a totally different approach. These tools are never going to be able to process data this large. And so we came up with this tool to handle large data. Color set is, I was frustrated with how many perceptually accurate color maps there are. So we came up with this package and so on. HV plot, we were frustrated with our own tool, HoloViz. We wanted to make it easier for people to use who know pandas. If you know pandas or X-array, you should be able to use HV plot. See, you can see me, but you weren't seeing my screen. So there you go. All right, so I should be, just replay that slightly. So you were just watching my mouth yammer, but pyviz.org has a list of all the tools that are available. holoviz.org is our own tools that we actually maintain. And so these are all tools that we create to try to fill in gaps. Each one of these are based on some other tools that are available in the ecosystem. We're not trying to replace anything usually. We're generally trying to make things easier to use, make them more powerful, fill in gaps. So that's the suite of tools we'll talk about is HoloViz tools. And one of the gaps, particularly one of our early clients at Anaconda was the United States Army Corps of Engineers. And they were doing a lot of hydrology modeling, trying to understand flooding and simulate water flow. And they were finding that the existing tools didn't handle their amount of data or their types of data. And so they paid us to make the tool, to fill in those gaps. And so we'll talk about some of those tools. And so I said there were three sites. There's pyviz.org, that's all tools. holoviz.org is our tools. And then the third site is examples.pyviz.org. This is examples that could be from anywhere, using any tools. Most of them are HoloViz examples right now. So it's called pyviz.org because any example is welcome here. But it is the largest collection of HoloViz examples. So I'll show off some of these and let you ask questions if anybody's allowed to ask questions. I guess not. Most people, well, the organizers are. So organizers, please ask questions and interrupt. And so what I'll do now is basically alternate between tutorial and example material. and try to show, and the goal is for you to understand what's out there, what's available from these tools, what they can do, coupled with a little bit of how to use the tools. And then I'll hand it over back to Felipe to actually, at some point during this week, to actually show how to try out using the tools in various cases, wherever they might be useful. So
before you jump in, James,
yes.
we have one, we're monitoring questions on the Slack tutorial Slack channel. And so if you just want to pause periodically, I can relay questions to you. So we have one.
Yeah.
Are these tools built on top of Matplotlib or a separate thing entirely?
Both. So they are built on, these tools were originally built on Matplotlib. They came out of our work as academics at the University of Edinburgh. And at that time, we were building only on Matplotlib. And then we joined Anaconda and gradually started working with more people who were developing interactive simulations and interactive dashboards. And so we started building them on top of Bokeh. And then we started working with people who needed 3D. And so we started building them on top of Plotly. And now Plotly, Bokeh, and Matplotlib all have their unique strengths, but they all are, these days, they're getting towards rough parity. I think Matplotlib and Bokeh are a little ahead of where Plotly is, but people over at Plotly are working on that and are bringing Plotly up as well. And so basically, think of it as covering all three of those tools primarily. And that's a good point. Is we're trying to build on things where we're not trying to push anything aside and say our tool is better. We're trying to say, how can we make it easier to use these tools? How can we make it easy? How can we pre-process data to provide to these tools for rendering so that they can handle large data and other aspects like that? And I'll kind of show you what that means in a minute. Okay. All right. So let me just do some examples, preferably ones that are already running. Let's see. So this, on this site, examples.pyviz, you can just click on them. And if you just clicked on one of them, let's say, this is an unrelated one, just to show you the mechanics. If you click on it, you get a web page. This is a rendered Jupyter notebook. All of these examples will be a Jupyter notebook. And then you have two choices here. You can either download this project. That gives you a Jupyter notebook plus a list of the environment, which is a list of packages. Or you can click on this one and that views a deployed version of the notebook that you can actually visit and run. And so that'll be true for all of these examples. If they're at examples.pyviz, they are encapsulated, reproducible examples. There's always at least one Jupyter notebook, and you go there and you can, if you download the project, you should be able to run that notebook in that environment. The ones that I'll show you are generally the deployed versions. So here's an example from our initial work with the Army Corps of Engineers. They were trying to model this, the Delaware and Chesapeake Bay here. And their particular type of modeling is tri-mesh based, where they have irregular unstructured grids, and the density of the grid is low out in the open ocean and very high in the tributaries. And that's very important for how they handle things. And there wasn't a tool that could render that in Python efficiently. And so they paid us to take our existing data shader tool that could render large numbers of points and make it able to handle large numbers of triangular mesh grid points. And so I guess this one's running. Well, I had started it running. We'll come back to that for a running version. But if you, what the tools allow you to do is take some data that's been, that exists in Python, either in Dask, so it doesn't necessarily exist in Python's memory, but if it's available to Python, render it off screen and then embed it on screen into a plot that you can see. And in this case, we're using, you can see lots of tools that work at this one little plot. This is a bokeh plot. And behind it, I screwed this up earlier. Behind the bokeh plot is a set of web tiles from OpenStreetMap. The part in front here has been rendered by Data Shader and then embedded in the bokeh plot by HoloViz. So these will just be names I'm throwing around, and we'll get to that in a minute, but hopefully you'll get some idea what that means. I'll show you maybe a better running example here. This one, This one is broken because it looks like Esri's map server is offline at the moment, which is kind of weird. That has never happened before, that their map tiles are gone. So this is generating a bokeh-based plot where it's dependent on this external map web map tile server, and if that's not available, it's not going to be able to be usable. But here's an example, at least, of what it means to have this whole set of tools stitching together to achieve something. So let me select this little section here. Actually, let me switch to a locally running version here. So what happened here right now is this is actually a local version of the same thing. And let me show you the code first. The code for what I'm running in this tab. This is the code for it. 1, 2, 3, 4, 5, 6. 6 little cells worth of code. And what this code does is set up this plot, this plot, this plot, this plot, and allows them to be connected to each other so that if I select here, it'll show the subset of this is a bunch of glaciers all over the world, and showing that if I select the glaciers that are in this, I can't quite read that, latitude area and this latitude and elevation, that's the average temperature for those glaciers compared to the entire set of glaciers. And it's showing that those particular ones are located in this particular part of the world and have, I hate where Zoom covers up what I'm trying to read, and they have this kind of average level of precipitation. And all of that was done with this Jupyter Notebook worth of code here that defines the plot, defines this overlay, defines the interconnection between each of these panels, and handles the fact that this is 31,000 points selected out of some 200,000 glaciers available, and renders that off screen, passes it to bokeh, displays it in your browser, and connects all that up. That makes sense, sort of? Like you can sort of see how, what it is we're trying to do is we got data, and then we're trying to show it, and we're trying to show how everything relates to everything. This is all done at a much higher level than the underlying tool bokeh or the underlying matplotlib. These are all expressed at a very high level. I can actually show you the code for that, which is the code for the thing that's running right here. Here's code. Import a bunch of stuff. Load some data, in this case into pandas. Project into Web Mercator coordinates. And then create a set of map tiles. Create a set of points overlaid on the map tiles. That's this, and then these little colored points here. Let's see if I can zoom in there. Okay, so this set of map tiles is overlaid on top of the map. So that the points are these geographically located points that are being overlaid on top of the map server. So this is the map tile server. This is the points. This is the elevation versus latitude plot. That's this one. So that's creating this plot. This is using something called HV plot. Come back to that. We're just trying to give you an appreciation for how things kind of look and feel before we dive in too much. This is this other plot here, temperature. Temperature is a histogram. And then precipitation, actually the precipitation's over here. So we create these plots, then we lay them all out together. This means overlay the points on the map tiles, lay it next to the scatter, lay it next to the temperature, and lay it next to the precipitation, and reformat it into 2 columns. Okay, you can see how that looks here. It's putting this, overlaid points with, overlaid the tiles with some data points, and then it puts it next to elevation, temperature, and precipitation. Okay. And then we're about halfway through the notebook. Yes.
Could I ask you to, if you can, increase your font just a little bit, font size?
Sure. should at least be 100%. So is that readable? Okay, we'll do one more. Okay, so just from the top, we imported a bunch of stuff. We loaded a data set. We projected the data set into Web Mercator. I know it's not a great system, but it's what Bokeh uses. Then we created these bunches of plots, and then we laid out the plots next to each other. And then, so that gives us all this stuff here on the right. Here, if I increase the font size, it doesn't fit on this one. So that's why I was down a minute ago. So I'll switch back and forth. But here, what we did with the code so far is to create these 4 plots here on the right. Okay, so that's that's all using the tool called hvplot. If you're aware of pandas.plot and xarray.plot, this is the same, but it gives you an interactive object. And then the interactive object is now available to be compositionally defined into other things. So normally the result of h3.plot is df.plot is a matplotlib figure, and it's hard to directly combine those. But this particular one gives you a HoloViz object, which is easy to combine into subfigures and such. So let's say you've done that. You got this plot here. Now we're going to try to set up all this interactive functionality where you can select a certain region of a particular plot and have that linked to all the other ones. So if we were to look at only the ones with very low temperature, let's say, actually that'll now be the intersection, but so now the intersection is 0. So let me start from scratch. Okay, let's select all of the ones that are very low temperature. You'll probably see them show up. My assumption is that'll be the ones high in latitude. Seem to be selecting it though. Oh, there we go. Okay, yeah, that was a good prediction. I actually had never done that, but if I select the ones that are average, low average temperature, it's the ones all around Greenland. So that's not too surprising for a bunch of glaciers. And by definition, and those are going to be the high latitudes. They show up here and so on. So how did we select, how do we set all that machinery up? That uses magic. So here's the rest of the magic. It's only been somewhat magic before. Now it becomes total magic. Also, we had it, notice that it's got this thing up here that says the total area, the number selected and the amount of area, total area of glacier that you've selected, which is 40% of the total glaciers available, glacier area. So how did that get calculated? Well, we wrote a function for that, and the function returns some HTML and tells us which was the area unselected. And so what does that depend on? This is actually the newest work that we're currently working on that has made this nice and clean, which is, it depends on this thing that, up here. We told it to, there's this thing called link selections. We'll maybe get a little bit into that, but not really. What that does is basically go through all these plots and find out all of the things that where they share a dimension, like latitude, and link those up. So that if you select on one, it's selected to the other. So maybe I can't go into that. I'm putting the cart before the horse trying to explain that. But anyway, all it is we've been able to put everything on the same page. We've been able to link them all up. And then we've been able to write this arbitrary function that takes this selection, which is what I selected down here, some selection by, in this case, a filter by average temperature, and use that to filter the data set and return some statistics about it. So hopefully you're sort of okay with this. It's still hand wavy, that's fine. And then we added the ability to have a clear button, which is here. So we added a little special widget. That was, we created a widget. This is using a library called Panel. Panel is what's controlling this whole layout. It has this template that's nice and lets you do a selection. So again, I'm doing a blitzkrieg so you see what's available. And then we wrote a button, and all it does is clear the selection. When the button is clicked, it's gonna call the function clear selections, clears the selections. That's all that does. And then we wrote some instructions and added a logo. Here are the instructions. Here's the logo. And then we created this kind of overall template using this, if you know JavaScript, it's the Material UI template. And then put that all together and we told it to launch a server. And the server, now that it's been running, has accumulated some errors. I don't know what those are. Something I selected that wasn't valid. I don't know. Okay, that's everything. That's a complete app that does projection. It does points. It uses data shader to render things off screen so they can handle large numbers of data. It uses selecting and connecting everything up. So this is kind of what you would build up to. And this is the amount of code that it takes to build up to that with HoloViz. Okay. So have any more questions accumulated in the chatter?
There's a little bit about where these examples are, but I think people are sort of answering it on the fly. Are there any confusions?
We haven't found it.
I guess that the problem is this. I did the HoloViz example fetch, but these glaciers is not there. I think it's on the pyviz.org.
Yeah, it's on examples.pyviz.org. And yeah, unfortunately, the glaciers one is one that's, I'm going to need to send you a pointer to that later today. There is one there. It's under glaciers. Where is it? Glaciers. There it is. So this is the same app. This app has actually gone through 3 iterations. There was first a panel and Plotly Dash and Plotly version. And then we said, hey, we could do that with panel a lot easier. And they said, really? And we said, okay, here it is. And then that's this version that's on this website. So if you go to examples.pyviz.org/glaciers, that's the fundamental data that's being involved and the functionality that I'm showing off. That is all covered by this app. But if you look at this app, you'll see it first loads the data. Then it creates some plots, slightly different styling. And then it does a lot more code to handle selections, and it does a lot more work. Basically, what we've done, and then it eventually creates it and creates an overall app, and then you get the same app that we ended up with. And so what I'm showing you is actually our very latest. It's kind of a tantalizing, teasing thing. I'm sorry, which is. We have essentially thought of what happened in this Glaciers Explorer and thought, how can we make that easy for everyone to do for everything all the time with no code? And the fundamental thing that we now make it possible to do, this was written using code that's been around for several years, 2 years now, I think. So it's new, but it's not that new. So if you go to that, you can totally reproduce this and run it. That's what you get when you click on this and you go to this running thing that's currently being blocked by Esri. And that's totally okay. That's legal code. What I just showed you is our newest interface to do that has boiled it down to its essentials, which is if you create a plot, you've defined what the coordinates are, and you should be able to automatically link that to any other plot. You should be able to select on it and have the selections reflected everywhere without any more work from you. And you should be able to put an arbitrary little widget up there, arbitrary little bits of text, and those should all be automatically linkable to everything without you having to do any work. So that's what I'm demonstrating right now, which is kind of the best case scenario, which is if it's an area that we really worked out a model of and a theory of this high level task of building a visualization and understanding a multidimensional data set, if you fit into what we've worked on, your life will be very easy. It's not always that easy. What if you don't want to do something totally crazy? Well, have we had to do it before or not? And so we're filling in gaps and we're making things easy for the use cases as we encounter them. Later today, I'll give you a reproducible version of this notebook. So this is the code for the notebook. It's depending on a release that's still building of HoloViz. But as soon as that builds, I'll be able to give you something you can reproduce that locally. But it's the same functionality as what's already fully available and can be used today right now. It's just much easier. So, all right, any other chatter first?
Not seeing anything else on Slack, so
okay.
Yeah, carry on.
Well, let's see if any of this other stuff is currently running. So again, I'm not an oceanographer and I don't make any distinction between geospatial and ocean. but I noticed this example of ours has an ocean in it, or at least a gulf. So this is the Gulf of Mexico. So just sort of illustrating some of the things you can do. And also it should illustrate some of the processes involved. Did you notice there that it looked pixelated at first? If I zoom in, you should briefly see a pixelated version. And then in this case, I think I've probably reached the limit on the Landsat resolution. But let's say you started out far out, and I quickly zoom in. You should briefly see a pixelated version of that plot. And what's happening there is that my browser, and Bokeh is running in my browser. Bokeh is a general purpose JavaScript-based plotting library. It's running in my browser, and it's displaying something and is able to increase the size dynamically in my browser. And as soon as I stop, though, it sends a message to the server. The server has access to the underlying raw data. It re-renders it on the resolution of the display and displays it. So you see this lag here, and before it updates, that lag is a round trip to the server. The server is updating to my new viewport. And so if I drag or pan around, it needs new data. So it dragged around what it could. Bokeh has a little bit of the data locally, and it plots that, but then it has to wait for the rest of it to be filled in by the server, and you'll watch the server fill that in. And so this is kind of illustrating the fundamental, the way that we make it practical to work with big data, which is that we've got a browser, they have memory limitations, they're slow, but they are very interactive for what they can do. See how fast that updates locally? It's not making a round trip to the server whenever I drag that around. But when I stop, it probably generated 1 million requests to the server while I did that. Eventually it'll catch up though. The server is going to render some stuff, and then it we'll send it around and it'll be displayed. Fundamentally, that's how you should think of these HoloViz tools, which is that we can handle any size of data that your server can handle. We don't care about your client. Your client just needs to be able to handle the screen. So your client is a Jupyter notebook, or your client is a locally running browser. That part doesn't have any computational requirements. The data, it doesn't need to handle the data, it doesn't need to handle the computation, it does almost nothing. As long as you have a big enough server somewhere that can be sitting there answering your client events. I just had a drag event, and that requires a re-rendering, and that requires it going to the server, re-rendering it, and bring it back. And the same here, if I managed to kill it, whatever I did there. But that's basically how any of these things become possible. Like, here's a bunch of GPS trackers somebody put on some gulls. I don't know who they were, but they published some data about it. And if I go to this, this is just a standard web page with some HTML on it. If I zoom in, it's going to make a request to a server that's not running. It will never update. I would have to go look on this running version of the notebook for this to work. So try to keep this straight. As we have tools that are primarily JavaScript based, that work in your web browser, they work in Jupyter, but they are tied and tethered to this Python server if you want to be able to have them dynamically update on demand. All right, so I won't show any more. I don't think. Oh, I'll show you one more thing before I actually start over from the top and try something you should actually try yourself in follow-on work. And that's if you're doing any machine learning or setting up simulations, you should be aware of this example, ML annotators. What this does is allow you to take, if you can get a plot, just like I showed you before, here's a plot with web tiles on it. Here's a plot of some data. Here's a plot of data on top of web tiles. As long as you can get there, what if you wanted to input from the user the location of every one of these trees, or the location of every one of anything? If you read this web page, it'll tell you about these tools in Bokeh that'll let you dynamically add data and annotate the data, put in some classification for it, or if you're setting up a simulation, you might define a region of interest, and you might define some initial conditions for any data you can plot. This will let you collect the data, whether it's points or regions. square regions or polygon regions. And so on. So you should be able to use these tools to collect data visually and from people if you're ready to run something practical. Okay. All right. So for the remaining time, I believe I have 14 minutes. Is that correct? Okay. So now I'm going to hand over to you guys conceptually. From the moment I've been waving my hands a lot. Look at all this great stuff. It's amazing. Blah, blah, blah. Confuse you entirely. Now I'm going to sort of take a step back and start you with something you can run yourself. This is definitely available. If Felipe said he was getting this installed on Jupyter Hub, but if it's not, it's what I'm showing you here is on holoviz.org. It's what's linked under talks. It's just the first talk, the only talk that's there, which is an intro talk, and it should be installed if you install our package. It's a Jupyter notebook. It's just this particular Jupyter notebook. And it just illustrates how everything kind of fits together. Starting in this case, I'm sorry, it's starting from a pandas data frame. Some of you, I assume, are, but in other cases, you'll be starting from Xarray. It doesn't matter. These tools work pretty much the same for Xarray and for pandas. You start with some data set. And then if you had a pandas data frame, so you should be able to run this notebook yourself. This is just running locally on my system. This example is not important. What's important is you have a data set. And if you had a matplotlib based pandas plotting or Xarray plotting, you'd be doing something like .plot. In this case, it wouldn't be useful. You probably need to do a little bit of work. And then now you get a useful plot, which is in this case, measles incidence over time. It doesn't matter what it is. You get some plot. You can do the same thing if you do this, import hpplot.pandas or hpplot.xarray or hpplot.dask or like 10 other things. All have hpplot interfaces. And if you do that, then what you get, instead of being this a static image, or sometimes you can set it up to give a IPy widget space thing, this will give you an interactive bokeh plot. And then it's an interactive bokeh plot that has affordances, as we call them. We're from a psychology background. And what it means is you get this plot, and it's not a dead end. This plot here is kind of a dead end. It's a picture. You could pop it onto a web page or something, or put it in an email, but that's about all you can do with it. This is less of a dead end because it's interactive, but it's very much less of a dead end because you can take the same thing you got here, the result of calling hbplot, which is right here, and then you can do other things. You can overlay things on it. You can lay it out next to other things. You can do lots of things with this. It's a rich object that you can now, there's not a dead end, and you can now compose and select between and do stuff with and get the data back even. And so it's, this is what lets us build up all the things I showed you there, which is that we're treating plotting not as a dead end, but as every step along the way, something is plottable. It's plottable, but it's not a plot. This is an object that you get back here. If we look at what is this thing that you got back here, you look at a plot. What is the type of that thing? It is a HoloViz element. If you print
James,
it,
could you increase the font a little bit? Just one bump.
Yeah, I have to keep switching back and forth, but let me pull that. Okay.
Thanks.
So where I was right here. So if I did print this thing, you can see it's a curve of measles each year. This is this particular object is of type curve. It's a HoloViz. So I'm trying to explain what happened here. Sure, I got a plot, but what did you really get at a Python terms? If you actually want to use this thing, what is this thing? It is, the thing you got back is a HoloViz curve. A HoloViz curve is represented like this. It's a curve of where the independent axis is year and the dependent axis is measles. So measles goes on the Y, that goes on the year. And if you, but now that you've got it, you can do, so you can plot it, but you can also do You can also overlay something on it. This is our overlay operator. So if you've got a plot, you can overlay it. You can overlay well, basically this thing. So now we just took the plot and we overlaid a line on it and we overlaid a bit of text. So you can hopefully see that this is not a dead end, this plot. We've caught something and then we can keep building and building and eventually end up with a dashboard, or you end up with a figure for a publication, or you end up with whatever you want. You end up with things next to each other that are related, or things that are linked in some way, or things that together add up to more than just the individual thing that you just did. And so basically that's all that happens in the rest of this notebook. We just keep doing it. Everything you do ends up like that. Like here's M. This is this whole thing together. Well, what is M? Print M. M is, now it's an overlay of a curve, a V line, a vertical line, and some text. And the type of M. The type of M is a HoloViz overlay. Or if you just display M, it's the thing. That make sense? Like, basically what we're doing is we're starting with data, we're ending up with something that displays as a plot, but then keeps going more. You can keep going further. You keep annotating it and adding stuff to it and overlaying stuff and building it up and putting it next to something else. Like if you do M plus M, that would be 2 copies of the same thing next to each other. And I don't like that, so I want to make it be in one call. So now it's in one column. And I don't like the color of it. So then that's probably in this notebook somewhere, but ops color equals, I don't know if that's right syntax. Looks like it is not. It's probably line color. The syntax here depends on the back end. It differs between bokeh and matplotlib. What you're doing with this option here is you're actually passing that down to the plotting library, and I always forget what the options are. There'll be some option for that. I think it's BG color if you want the background. I don't know, I'll get to options in a minute, but hopefully the basic idea makes sense, which is that we are trying to take data and create this object that we can now work with. This is very unlike a plotting library, where the whole point of a plotting library is to start with data and end up with a plot. Here, a plot is something along the way. It's a branch. A plot was on screen, but forget the plot. I got what I could out of the plot. Now I keep going with this data, and I end up with this structure, like this structure M here, that I can keep building on and keep going to, and eventually, if it needs to be a dashboard, it's a dashboard. If it needs to be a complex 17 subpart figure, it is. And you can always go into that 17 subpart figure, pull out one little bit of it, and work with it. Pull out the data. What is the data behind this plot? What is the value at 1960? Well, there's probably an example already here where I do that. So that's one thing you can do. The other thing you can do is you can automatically work with data that's too big for you. In this case, let's say we grouped our data by year and by state, and we wanted to plot the measles incidence. And so we told it as a plot of year, and it's going to be grouped by state. And unless we told it something else, what that means is that the data is plotted year, measles per year. But then what happened to the state? Well, the state became a widget. And that's because it's been grouped by year, but we didn't tell it anything else to do with it's been grouped by state. We didn't tell it anything else to do with the data. What do you do with all these states worth of data? You have 50 states worth of data and you've got one plot. What do? You could tell it to do things like you could tell it to, that's too complicated. You can tell it to do lots of things. In this case, the default is to pop up a widget and say, which state's data? I want Delaware's data. And this whole object here, again, is something you can put layout next to something else, put it in an overall plot, become a dashboard or whatever. So, and once you've got it, let's say here's this object called by state. What is by state? It's always an object, it's always something. This is a map by state of a bunch of curves. And so once you've got this object here by state, you can show it if you want to, or you can keep going. and then pull out just the Texas from that, or just the New York from that, and show that next to each other. So here we're taking this and we're pulling out one item, we're pulling out another item, and we're putting next to each other. Or we could pull out 4 states, and then there's by and group by. By default becomes an overlay. Group by becomes a widget. You can always convert from one to the other, so it doesn't much matter. But in this case, we've pulled out all the data and then plotted it by state in the same plot, which makes it all crammed up together kind of uselessly. Or we can take the same thing and instead of doing a by or a group by, we say that the state is it should now be a column. And now you'll have all the stuff laid out left to right. Or you can take the same thing and create a bar chart or all sorts of other things. So I want to get into those. I'll kind of skip ahead to the more geo example. But the final result of that is that you can come up with, in 4 or 5 lines, you can come up with fairly detailed, interlinked plots with aggregates along the side, hovering, heat map, whatever. It all kind of feeds into the same. The code is all designed to make that as easy as possible. And then the last thing to show is kind of related up to the glaciers example I showed before. This is actually earthquakes instead of glaciers. So at least some of those happen in the oceans. They might be relevant. How does that work? This is this code should be familiar to you from the glaciers example, but here it's actually, there's less of it and it's more straightforward, which is we create some options. We create some tiles, exactly like we did for that example. Some map tiles. We load in the data from a bunch of earthquakes. It might be a little less obvious because it's actually using Dask instead of pandas here, but it's using Dask. All you do is get a Dask data frame. Yeah, this is a Dask data frame. It can also work with Dask arrays, but this is a Dask data frame. And then we write a little function that will plot the data on top of that. And then we put that together into a tiny little app where you have a little row left to right of a column of some text and some widgets and a plot. And then that's all you need. So if you start at this part right here where it says branching out, and then just ignore everything above it, probably for your cases, this is a good starting point. And this will just get you from 0 to this app where you can select the color map, and you can select how visible the background is, and you get a little button. So it gets you from 0 into something that might be relevant very quickly. And I think that's it. So I got you to the end of some actual runnable code that is self-contained and tries to explain things, so you can go back and read that. Everything I skipped over, you can read. I wrote those words there, and you can read them there instead. And it gets you up to the ability to be able to plot some points. But note that these could be rasters. These could be lots of data types. It could be tri-meshes, raster data, whatever. Whatever your format of data, it's almost certainly covered somewhere. Quad meshes, whatever. Okay. Any final questions?
Thanks so much, Jim. There's been a little bit of back and forth about sharing images or PDFs or interactive plots on web pages.
Yeah.
But it was sort of as you were explaining things. So I don't know if there's anything
Yeah,
you
that's
want
a
to
great
add to
question.
that. Yeah, go ahead.
Yeah, that's a great question. So if you use the matplotlib backend, this is using the bokeh backend. If you use matplotlib, then you have easy SVG output. And so you can easily get from SVG to PDF or any other vector format. So the SVG, matplotlib backend has great SVG support. The bokeh backend currently has very limited SVG support, and we're getting, we've actually applied for some support from Shannon Zuckerberg. So if you know anybody there, tell them to approve it to have better bokeh SVG rendering. And right now that's a little tricky. It doesn't save the whole layout and it's complicated. But if you do use Matplotlib, then you get beautiful publication quality layouts. However, switching between Matplotlib and Bokeh, all the core code is the same, but these options have different names. Like they'll be called size in Bokeh, it's called S in Matplotlib. So it's not a trivial, it's a pretty easy thing to do, but it's not cost-free to switch between backends. So it's annoying if you wrote it for Bokeh and you have to switch to Matplotlib to get your great SVG output. But it'll take you like a half hour because you have to look up what is that called in Bokeh, what is it called in Matplotlib, and convert it. So getting those out in SVG is, I would recommend use the Matplotlib backend. If you don't want it to static HTML page, well, as long as you get it set up the way you want it, this is a static HTML page. This is just using like NB convert. We'll convert this to HTML. That's what you get here. It's a static HTML, and as long as you don't need to do anything with it, as long as you don't need it to update ever when you zoom, you're done. Export it as static HTML, you're happy. As long as it doesn't need something from Python, it's just HTML. It's HTML, JavaScript, CSS. It's totally distributable. And then if you want to share live Python, well, then you got to put it on Heroku or Binder or something like that where there's a live Python running. So those are your options. They're all good.
So I'm going to take the opportunity that you have that image there just to comment a little bit about that's in there. If anyone here tried to plot a tri-mesh with that kind of fine detail, you know that's pretty much impossible. You have to either rasterize it or subset it or create a single polygon from all the small polygons. But what they have there, it's actually a live mesh. Every time you zoom in and out, Bokeh on the back end, together with Data Shader, will recompute that mesh to show you all of that in fine detail. But
right.
That example is for us as oceanographers and modelers, it's pretty much the only tool out there that allows you to do that. I don't know of any other tool that can do that.
And that's not an accident. We were paid by hydrologists to make this happen. So before that, we had Data Shader, but Data Shader handled very large collections of points and sometimes, in certain cases, raster. But it didn't handle quad meshes. It didn't handle tri-meshes. We were specifically paid by climate scientists and hydrologists to handle both of those cases. And now it's fun.
A question maybe for both James and Felipe, but I'll start with Felipe. Is this capability available in the version of HoloViz or Data Shader that we have on the hub?
I haven't tested, but I'm not sure that is.
Yeah, everything except this one.
Okay.
This is the only, this where you have only the very little amount of code to create the entire app. That one is new, but the other stuff, this is all completely released and available for some time.
Awesome. Thank you.
All right, great. Well, thanks so much, Jim. That was really great.